Okay, not going to take long. Okay, I'm going to talk how I'm going to teach 547. It's a very unique class. It's called software measurement. Okay, so this is actually one of the unique classes that usually not appear in a software engineering program. Okay, so because measurement is everywhere. Every engineering, civil, mechanical, they all do measurement. They all do metrics. Software is kind of unique. It's kind of difficult. This is one class we can actually, it's an opportunity to help us to put everything together. Okay, so measurement obviously is very, very important. Okay, so that has not been really utilized. Okay, and let's consider a few simple examples in real life. Everybody drive, right? Imagine there's no gas meter. Can you drive? You still can drive. Okay, but it's very inconvenient, right? Would cause some problem. You know, in the past, I don't know, 15 years, I have been in a cycle. You know, people, my friend, they see me, they will say, "Oh, you gain some weight." At the same time, some people, "Oh, you lose some weight." Obviously, depends on when they saw me last time, because I've been struggle doing this, you know, so trying to lose weight because I have a sugar level problems. I got sleepy in the afternoon. I'm talking to him. And you know, the doctor says it's very important for you to lose the weight. I try. So it's very difficult. When you try to lose the weight, I assume you're going to have a scale, right? You imagine, but do you, if you have a scale, is it guaranteed you're going to lose weight? Whatever, you don't have a scale. Okay, well, no problem. Right? So I tried. I tried exercise. I tried to change my diet. Are they effective? How the hell you know? Okay, look at mirror. You could do that, but it's not very scientific. Okay. Now, you know, one thing I do, this is truly personal. Yeah, you know, diabetes. One of the problems every morning I do. Doctor asked me to do twice. I said too much. You have to use a needle to do this. It's a hurt. So I just do it in the morning, every day. I actually build a control chart, automatically. You know, test up, down, up, down, up, down. That's measurement, right? Why I do that? You know, hurt myself. Because number one, I want to know what is my current normal range of my sugar level. Number two, because I try to control, I try to lower. I eat a bunch of pumpkin. I eat, you know, I try to eat healthy. And, you know, never, a lot of things I try to avoid. Sometimes I try something new. Okay, so every time, every morning after I got a new result, I plug into my Excel, which automatically generate you can learn this, a control chart, XMR chart. Okay, and I know my normal range. If it's in the normal range, I do nothing. Normal. But if it's too high or too low, because I know, right? It's control chart, too high until I have to analyze. So basically, there's a warning sign. If it's too high, oh, okay, what? Then I have to think, what did I do the day before? So how come this? What's the driver for this? Oh, I eat a certain food I did not eat before. I'm gonna say, oh, this one is bad for me. Then what? I'm gonna try to avoid that in the future. I cannot eat that. Okay. Or if it's become extremely low, that's good. What did I do? I eat something. Oh, I exercise. I walk and I did this. Hey, maybe I should repeat it. See, that is the value of measurement. Quality is the most common term we hear in software, right? Go back to a company, ask project manager, ask tester, ask QA, ask product line manager, ask department manager. In your eye, what is quality? How you define quality? You're going to hear different answer. Trust me. Everybody talking about quality. What the hell is quality? What's a good quality? What is a bad quality? Okay, so sometimes common sense. You know, everybody understands. We work in a field. Everybody is smart. Software is, you know, all smart people. Smart people sometimes they don't do common sense thing. Do you have a common understanding? If the understanding of quality is different people, different stakeholder, how the hell the organization can put effort aligned to achieve quality? Everybody's understanding is different. Okay, this is another example of why measurement is important. Okay, and so through those examples, common sense, okay, and you know, maybe you can see some insight why we have to bother in software engineering. Talk about outcome. What's a good outcome? We can't talk about a feeling. Okay. And what's the driver? Okay, so common sense means what? When you make a priority, how you decide your priority. So engineering probably have all the different processes. Which one are the driver? How the hell you know? Based on feeling? Based on past experience? Or based on the proper set metric, the proper set collected data? Okay, that would decide winner and also loser. Okay, so this is basically, you know, what we try to do. And the textbook, I'm gonna, you know, it's an old book, Measuring Software Process. The reason it's also relatively old book. The reason I still choose this book is the reason very simple, is because this is the only book. And so some of you probably heard the term SPC, Mr. Deming, statistical process control. Okay, and he made a name for himself, you know, because of that. Okay, how we obviously would like to apply that to software. And this is the only book actually talk about how to apply SPC in software setting. We already discussed. Some of you probably familiar with Six Sigma. Six Sigma most successfully applied in manufacturing, but the process is repeatable. Software, the process is not repeatable. And obviously there must be some nuance. There must be some change when we apply the same concept. And nobody talk about how to do that in software. This is the only book. Actually, you know, focus on software, one discussion, apply SPC. So we still use it. And the meat of the book is chapter 4, chapter 5, chapter 6, chapter 7. The first 3 chapters lay the foundation, mechanics. Okay, 4, 5, 6, 7 are the meat. Okay. And you know, there are a few other books I want to talk about. The reason I mentioned the software testing book is because the one of the measurement is what? Defect analysis. Right. So if you look at the in case, I think in English it's using different book. That's okay for now. You don't have to worry about it. The chapter 11, chapter 16 is about measurement. It is about a defect analysis. You know, so when we measure quality, usually traditionally people look at defect data. Okay, so Humphrey actually started that in IBM. He requests, you know, every team need to analyze the escape defect. How come we inject those defects? How come we do not catch them? So they reach to the user. But that one, if you do not use it, don't worry about it. John Doe, very famous, you know, measurement book. This is a bestseller. Measure what matters. Some of you probably heard OKR using Google. Okay, so a lot of good stories. And you know, he's from Intel. He actually is an investor. Obviously, his most valuable, highest ROI investment is Google. When Google was small. Okay, so you know, he also invests in many other companies. Not only he invests money to Google, he invests management technique, what he learned from Intel. so which OKR, and he wrote a book, and he also doing consulting, and charge people millions of dollars, teach them how to measure. Okay, so measure what matters is a good book. A lot of story, a lot of example. Okay, so it's easy read. It's a kind of a good. Another one I'm gonna post. You will see a lot of good video on this. Douglas, Harvard. There's a great book. It's called How to Measure Anything. It's another very popular book. So these two are most recent. Okay, there are a few other paper Jones. Yeah, actually, we invite him give a talk last semester. His whole life built on software measurement. Any type of benchmark data, you want it, he got it. But obviously, the talk he gave is about AI. He's 86 years old, live and learn. He insists on, I don't want to talk about measurement anymore. I want to talk about AI. Okay. Okay. And so, statistics is very interesting. Okay. And this book, in my view, is the most entertaining book on statistics. I tried 200 of them. Okay. Elementary statistics. So I don't know how many edition. The guy, the whole life, just write a book. Same book. Yeah. Excellent book. All the best example. Help you understand statistical thinking. In software engineering, there's three thinkings. One is system thinking. Yeah, you learn that, right? One is process thinking. When we try to solve a problem, we're going to look at it from process point of view. So we solve it. We do not make the same mistake again. How do you ensure that? Another one is statistical thinking. This is actually engineering basic skills. Okay, so obviously going to help you understand the issues a lot better. Okay, and there's a few other books. Okay, so you don't have to, if you're interested in, if you like to read. I don't have a lot of hobby. One thing I like is reading. I don't know, recreational reading and kill some time. If you love reading, there's some book. But I will recommend the Measure What Matters and How to Measure Anything. So those two, and also I'm going to post some video from the author, so you hear from them what's important. But the last one, I'm gonna make sure everybody gonna study, called Dora. That's my daughter's name. Dora is, actually means is dealing with DevOps. Okay, productivity measurement. How the hell we measure productivity? Every manager wants to know. Nobody knows how to do that. With DevOps, now we figure out a way to do it. And Dora is now, I think this is actually a work start from Google, and now today became the industry standard. Okay, 4 simple metrics. Okay, it's become a benchmark. Help us measure teams' productivity. Okay, it's a very interesting concept. And also there's another methodology called the SPACE. It should all be capitalized. Okay, and this is, I guess, what's new in software measurement. Okay, so I'm going to post a lot of lecture, a lot of paper, and some of you, maybe some of your company may already use it. If not, excellent reference. A lot of good material. Okay, so maybe obviously I'll post some other stuff. Okay. The coursework, I read all your feedback, I try to improve, but there's a constraint. I will, a discussion board, I still like it. As a discussion board is opportunity for me to present some new stuff. And also you can talk whatever, no limit. Respect each other, new idea. Okay. We're still going to do it. We're going to try to do 8. This mostly created by effort. Okay? And share your knowledge, share what your thought, okay, and share what you learned, I think this is a opportunity because in MSE we have a lot of knowledge within our student, a lot of your practitioner. Okay, so I always have a high respect for people in the first line building software because I know it's not easy. I know there's always a skill set shortage. I know the resources is always a problem. I know the customer users sometimes not very reasonable. They want everything, they want no bug, they want it tomorrow. Okay. I understand sometimes managers don't understand your situation. Not helping. Okay. And I understand, there's communication within the team. Okay, so it's hard, but in many, many cases, you still can deliver a workable software. That means something. That means you're doing something right. Okay, so obviously that's always a starting point for doing it better. The term of improvement. Okay, any improvement, the starting point is what you're doing now. Starting point is not CML level 5. There's a gap. That's not you. The starting point is not what Google's doing. Because your context, your situation is different. Okay, so that's important. We have an exam. We're going to have a group assignment, and I'm going to try to make it interesting. Try to integrate some of the new things into the team project. Again, we're gonna try to leverage, a lot of new stuff. Integrate your interest, your learning goal, relate to what we try to teach in this class, and so. And this is, pretty much in terms of the work involved. Okay. This is the same. The objective, I'm not going to go through every detail. Okay, so you can read. So this is basically a few part. You need to understand the basic mechanics, the foundation. Okay, so software measurement, there are some mechanical things you have to understand. Okay, for example, operational definition. Okay, you have to make sure your measurement are comparable. Effort, that's a common measurement, right? A lot of company, end of the day, how much work you devoted to this, right? If obviously you want to find out at the end how much time we spent building this feature. Or sometimes I want to figure out what's the percentage in what? Requirement, in coding, in design, in testing, and in maintenance, or you have some idea about the effort distribution, so you need to collect data. Okay, but you know what? In many cases, is the operation definition of effort is not properly designed. One simple example. Do you count overtime work? Some teams we do. Some teams we don't. Then what happened? Can you compare? You can't compare anymore. Okay, so this is a simple example. It's called operational definition of make it operational, so you can actually use data. You need to have the trust. There's always noise. Okay, for example, what's the defect? Defect density. Hey, what the hell is the defect? If the definition is different, then what? You cannot compare. So this is basic stuff. Okay, the measurement the process must be repeatable. Everybody goes through the same thing. Otherwise, it's not comparable. If it's not comparable, it's not operational. You're going to use for evaluation. You're going to use for decide who getting more money, promotion. Oh, it better be very well defined. Okay, and obviously, what's CML high maturity? It's basically about SPC. Apply SPC in software management, software development, software process improvement. Okay, so those are the things we're going to learn, and hopefully we can gain some insight in terms of process thinking a little bit better. Okay, so what's the process? We talk about it over and over again. I always have a very simple definition. Is basically what? That my process represent my best understanding doing this thing. But is my best understanding the best? No. New things, new practice coming up, problem come up, I can improve. So I can improve my best understanding. Okay, and that also leads to what? A better result. Everything should be result oriented. Okay, and how we know if we got a better result, you have to measure. In the morning, at our meeting, ask, he actually sit through the whole process, talking about, improvement. He talk about measurement. So they have this optimization function where we need to improve something. Your company have an AI initiative. How do you know the initiative is successful or not? A lot of companies finish the whole thing. Oh, we get all the tasks done. Is that successful? I have no idea. Why? You didn't define what's success. What problem you trying to solve? Are you trying to improve productivity? You try to avoid certain problem? What are you trying to define? So you need to define the goal. The goal is the measurement, right? So then you have a goal. Then what? I can say what's my current level, right? Where am I now? Where I need to improve after I tried a month, a quarter, a half year. Look at it. How far what's the gap between what we achieved now and the goal? Do we need to make any adjustment? Right? When you do project, same thing. Okay, so many times we basically still govern, manage based on feeling, based on authority. Okay, and that's not the right way. In AI, you're going to base on AI? Well, at least you need to know the criteria, you need to know the outcome, right? Okay, so those are some of the things. And I don't like the term best practice, but I still use it. Yeah, put a quote, because best practice is always relative. Google's best practice is the internet company is not a best practice in resale. Best practice 10 years ago is trash today. There's always a context. There's always a situation. I always talk about good practice, effective practice. Okay, and you have to make local. You have to make it fit your situation. Every situation is different. Okay, so that's why in our software engineering, we have, even in the process is different from other process, is knowledge process. Okay, and also innovation is part of it. Okay, so, try out. Okay, don't be afraid. Anytime you talk about improvement, don't be afraid to make any mistake. It's okay. You make a mistake, always say that's a plus. Why that's a plus? You'll learn something. No mistake, no learning. For me, it's okay if I'm old. For you, it's bad. You want to improve. You want to do better. So we're going to learn some so-called best practice, new trend in industry like DORA space. There's a term called productivity engineering. I hate those terms. Usually there's a commercial reason behind, so you can do training, consulting, have all those fancy terms. Okay, but we just borrow it, and also use AI. Okay, so there are a lot of different new things, and here is what we have, like the order of the class, different chapter at the time. By the way, I'll post everything online. I'll do it tomorrow. Okay, I saw Ning already did, because the class start on Monday for online class. I'll post everything, most of the stuff tomorrow. I've been overwhelmed, by this. This one is okay, but the orientation, you guys went through this last year, so there's a lot of work involved, and also we have new people involved in prepare this also. So this is basically the sequence, the topic, tentative schedule. We're going to talk a little bit more, and also the project, some of the topic, and we're going to talk more. I'll make a video to explain, and so do not worry. I'll give you enough time, to come up, choose your project. So I have a tentative some dates, important dates. Okay, the due date of different things. I will formalize this and post it in a Canvas tomorrow. Okay, so I have to I guess validate some of the date. Try to be consistent because some students suggest maybe the due date should be all Monday or Sunday. Okay, so make it easier. Okay, so I always believe make valuable things easy to do. Make good things is let me give you an example. I read a book, so they say that I need to drink a lot of water. If you're drinking a lot of water is good for my health. The doctor drink 8 cups each day. How am I going to do that? I need to what? I need to make this thing drinking water easier for me. You go to my room where I watch TV, I have a bunch of bottles there. In my desk, I have a bunch of bottles there. In my bed, I got a bunch of bottles there, right? So what? Make it easier for me to drink water because that's good. That's a valuable things to do. Okay, so I think that's one, trick for improvement. Because anytime you do improvement, that means what? It's always hard and require courage. Because you're going to basically get out of your comfort zone. Okay, if you solve a problem, everything's easy, happy, no effort. I don't think you really solve anything. You make it uncomfortable, turn that to comfortable. That's learning. It's not for everyone, but it's a must skill for people working in software. Okay. And so we're gonna post this, and again, most lecture material will be posted by tomorrow. One thing I did recently for each chapter, I know I have some old audio, but for each chapter, I added a summary lecture. So basically tell you what's important, what's the core in that. I'm going to do that. Another thing I will do this semester, each week, I'm going to, based on the chapter, maybe I will try to add some interesting interesting perspective based on the material covered, maybe hopefully provide some better insight on the material covered. Okay, and thank you for your attention. And any question?